write 5 and 1/4 as an improper fraction. And an improper fraction is just a pure fraction where the numerator is greater than the denominator. This right here, it's not a pure fraction. We have a whole number mixed with a fraction, so we call this a mixed number. So let's think about what 5 and 1/4 represents. And let me rewrite it. So if we're talking about 5 and 1/4. 5 and 1/4. And you can literally think of this as 5 and 1/4 or 5 plus 1/4. That's what 5 and 1/4 represents. So let's think about 5. 5 is 5 wholes. Or if you're thinking of pi, we could draw literally 5 pies. We could draw 5 pies. And let me just cut up the pies from the get-go into 4 pieces, since we're dealing with fourths. So let me just cut up the pies right over here. So that's 1 pie right over there. Let me copy and paste this. Copy and paste. So I have 2 pies, and then I have 3 pies, and then I have 4 pies, and then I have 5 pies. So this is what the 5 represents. 5 literally represents, so let me circle all of this together. That is the 5 part right there. That is what 5 literally represents. It represents 5 whole pies. 5 whole pies. Now, I have cut up the pies into 4 pieces. So you can imagine each piece represents a fourth. Now, how many pieces do I have in these 5 pies? Well, I have 4 pieces per pie. I have 4 pieces per pie. 4 pieces per pie. 4 pieces. Well, let me just write it here. 4 pieces per pie times 5 pies is equal to 20 pieces. Or another way to think of it, since each piece is a fourth, this is also equal to 20 times 1/4. Or you could just write this as being equal to 20 fourths. So we have 5 whole pies is equal to 20 fourths. Let me write it like that. 20 fourths. Or we could write it as 20 over 4. I've kind of done the same thing twice. So that's what the 5 pies represent. 20 fourths, or 20 pieces, where each piece is 1/4. Now the 1/4 right here represents literally one more fourth of a pie, or one more piece of a pie. So let me draw another pie here. So let me draw another pie here. So that is another pie. Cut it into 4 pieces. But this 1/4 only represents one of these pieces, right? This is one of the 4 pieces. The 4, the denominator tells us how many pieces. The 1 tells us how many of those pieces we're dealing with. So it's just this one piece over here. That right there is the 1/4. Now, if we write 5 and 1/4, we just saw that the 5 right here is 20 fourths. So we could write this. So we could rewrite this. So let me write it like this. 5 and 1/4. 5 and 1/4 can be rewritten as, this is the same thing as 5 plus 1/4. 5 plus 1/4, which is the same thing as, we just saw that 5 whole pies is the same thing as 20 fourths. 20 fourths. And to see that these are the same thing, you literally just divide 4 into 20. You get 5, and nothing is left over. So 5 is the same thing as 20 fourths. And then this plus 1/4 is the same thing as plus 1/4. So if I have 20 fourths, and I add one more fourth to it, how many fourths do I have? Well, I have 21. I have 21 fourths. Or another way of thinking about it, this 5 is, so this right here is, that right there is 20 pieces. 20 pieces of pie. And you can even count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But a quicker way is to say, well, we have 5 pies. Each of them have 4 pieces. 5 times 4 is 20. This 1/4 right here represents 1 piece plus 1 piece. So total, we're going to have 21 pieces. So we have 21 pieces where each piece is 1/4. So you could say we have 21 times 1/4, or 21/4 pieces of pie. However you want to think of it, but we've solved the problem. We're at an improper fraction. We've written 5 and 1/4 as an improper fraction. Now, I've gone through great pains to give you the intuition of what 5 and 1/4 means, but there is a fairly straightforward process for getting straight to the improper fraction. If you have, let me color code it. So if you have 5 and 1 over 5 and 1 over 4, to convert it into an improper fraction, you're going to keep the same denominator. So you're going to have the over 4 there. But your numerator is going to be your numerator of the fraction part before. So it's going to be 1 plus your whole number times your denominator. So 1 plus, or actually, let me do it the way I tend to think of it. What I do is I take 4 times 5. So let me write that down. 4, and I want to color code it. 4 times 5. 4 times 5. And then to that, I add this numerator. So I literally do 4 times 5 plus 1, and which is, so this is equal to 4 times 5 is 20, plus 1 is 21, and that's over 4. So it's 21/4. And although this is kind of a fast way to do it, we're literally doing the exact same thing that we did here in a kind of a slower way. We're saying, OK, 5 wholes is the same thing as 20/4. So you take 5, and I figured that out, times 5 times 4. And then I have one more fourth there. So 4 times 5 plus 1 gives 21. Write 7 over 4 as a mixed number. So right now it's an improper fraction. 7 is larger than 4. Let's write it as a mixed number. So first I'm just going to show you a fairly straightforward way of doing it. And then we're going to think about a little bit about what it actually means. So to figure out what 7 over 4 represents as a mixed number, let me write it in different colors. So this is going to be equal to, the easiest way I do it, you say, well, you take 4, you divide 4 into 7. So you divide 4 into 7. 4 into 7. So 4, if we're dealing with fourths, 4 goes into 7 a total of 1 time. 4 goes into 7 a total of, let me do this in another color, a total of 1 time. 1 times 4 is 4. And then what is our remainder? 7 minus 4 is 3. So if we wanted to write this in plain, well, let me just do the problem, and then we'll think about what it means in a second. So you see that 4 goes into 7 1 time. So you have 1 whole here. You have 1 whole. And then how much do you have left over? Well, you have 3 left over. You have 3 left over. And that comes from right over there. That is the remainder when you divide 4 into 7. 3 left over, but it's 3 of your 4, or 3/4 left over. So that's the way we just converted it from an improper fraction to a mixed number. Now, it might seem a little bit like voodoo what I just did. I divided 4 into 7. It goes 1 time. And then the remainder is 3. So I got 1 and 3/4. But why does that make sense? Why does that actually make sense? So let's draw fourths. Let's draw literally 7/4. And maybe it'll become clear. So let's do a little square as a fourth. So I'm going to do it, let's say I have a square like that. And that is 1/4. Now, let's think about what 7 of those mean. So let me copy and paste that. Copy and then paste it. So here I have 2 1/4, or you could say I have 2/4. Now I have 3 1/4. Now I have 4 1/4. Now this is a whole, right? I have 4 1/4. This is a whole. So let me start on another whole. So now I have 5. Now I have 6 1/4. And now I have 7 1/4. Now, what does this look like? So all I did is I rewrote 7/4, or 7 1/4. I just kind of drew it for you. Now, what does this represent? Well, I have 4/4 here. So this is 4 over 4. This right here is 3 over 4. Notice 7 over 4 is 4/4 with 3/4 left over. So let me write it this way. 7 over 4 is 4/4 with 3/4 left over. Now, what is 4/4? What is 4/4? 4/4 is 1 whole. So you have 1 whole with 3/4 left over. So you end up with 1 and 3/4. So that is the 3/4 part, and that is your 1 whole. Hopefully that makes sense, and hopefully you understand why it connects. Because you say, well, how many wholes do you have? When you're dividing in the 4 into the 7 and getting the 1, you're essentially saying how many wholes? How many? So the number of wholes. Or you can imagine the number of whole pies. And then how many pieces do we have left over? Well, we have 3 pieces, and each piece is a fourth. So we have 3/4 left over. So we have 1 whole pie and 3 pieces, which are each a fourth, left over.
I've got pairs of mixed numbers and improper fractions, and I want to think about which of the two is larger. So 1 and 7/8, 39 over 10. So you could do this in your head. You could say 10 goes into 39. I'll even write it out. 10 goes into 39 3 times. 3 times 10. And you want to find the largest number of times 10 goes into this without going over. So if you couldn't write a 4 over here, because then that would be 40. That would go over 39. 3 times 10 is 30. And then you have a remainder of 9. So you could rewrite this expression right over here. Instead of 39 over 10, you could write it as 30 over 10 plus 9 over 10. And 30 over 10 is just 3. So this is equal to 3 and 9/10. And you could do that in your head. You could say 10 goes into 39 3 times, and the remainder is 9. You have your 9/10. And that's essentially just doing this in your head. So now we can compare, and we can literally just look at the whole number parts. This is 1 and something, 1 and 7/8, and we're comparing it to essentially 3 and 9/10. 3 and 9/10 is clearly a larger number. We have a 3 out here instead of a 1. So we will write less than. And the way I always remember it is the opening always faces the larger number, and the opening is large. It faces the larger number. And the point is small. It always points to the smaller number. Now let's do this next one. 4 and 7/8 versus 49 over 9. So let's convert this to a mixed number. 9 goes into 49 5 times, and 5 times 9 is 45. So the remainder is going to be 4. The remainder is 4. So this is 5 and 4/9. Once again, we can literally just look at the whole number parts. 5 is clearly larger than 4. So once again, less than. Point facing the smaller number, opening facing the larger number. Now, 2½ versus 11/10. 10 goes into 11 only one time. And if you care about the remainder, it's 1. So it's 1 and 1/10. Which is clearly smaller than 2 and 1/2. You just look at the whole number of parts. 2 is clearly larger than 1. So we want our opening of our less than or greater than sign to face the larger number. So we would write it like this. And this is greater than. So 2½ is greater than 11/10. The little point facing the smaller number. 5 and 4/9 versus 47ths. 7 goes into 40. So let me rewrite this. 7 goes into 40 5 times. And then you're going to have a remainder of 5. Because 7 times 5 is 35. You have a remainder of 5 to get to 40. So it's 5 and 5/7. And if that looks like I'm doing some type of voodoo, just remember, I'm really just breaking it up. I'm just really saying that 40 over 7 is the same thing as 35 plus 5 over 7. The largest multiple of 7 that is less than this number. And this is the same thing as 35 over 7 plus 5/7. And then this 35 over 7 is 5, and 5/7 is just 5/7 there. This one is interesting because we have the same whole number out front on our mixed numbers, 5 versus 5. So now we actually do have to pay attention to the fractional part of our mixed number. We essentially have to compare 4/9 to 5/7. And there's a couple of ways to do this. You could get them to have the same denominator. That's probably the easiest way to do it. So you could rewrite, so what's the least common multiple of 9 and 7? They share no factors, so really the least common multiple is going to be their product. So if we want to rewrite 4/9, we would write 63 in the denominator. That's 9 times 7. If we multiply the denominator by 7, we also have to multiply the numerator by 7. So that will be 28. Now, 5 sevenths, we're going to make the denominator 63. We're multiplying the denominator times 9. Then we have to multiply the numerator times 9 as well. 5 times 9 is 45. So here it's easy to see. 45 over 63 is clearly larger than 28 over 63. And so we could write this, and because the whole number parts are the same, and 5 sevenths is the same thing as 45 63rds, and 4 ninths is the same thing as 28 63rds, we can write it that 5 and 4 ninths is less than 40 over 7. Another way that you could have thought about 4 ninths versus 5 sevenths is you could have said, well, how does 4 ninths compare to 4 sevenths? We have the same numerator. The denominator here is larger than the denominator here. But when you have a number in the denominator, the larger it is, the smaller the fraction, the smaller the absolute value of the fraction. So this right over here is a smaller quantity than 4 sevenths. And 4 sevenths is clearly a smaller quantity than 5 sevenths. So 4 ninths is clearly smaller than 5 sevenths. So we would have gotten the same result.